permitted, but it passed the second time because they told me, oh, go back and change this not permit. Professor Story was just telling me he tried to get something permitted that for him looking at the code he thought would be permitted, but the fire marshal did not allow that. So this is a living document that's open for interpretation. So I am helping you to interpret going forward some of the ones that are stickier. So one of the ones that used to throw students off in the past was this one up here, the assembly. So we use the assembly to get the lobby, the gathering space, to get the urban room because that's gallery space, and to get part of the collections, I believe, if I remember correctly, because that's a gathering space. So you can say, oh, am I providing standing space only? Well, what happens if you bring a bunch of chairs into the space and the fire marshal happens to be there on that day? This is unconcentrated tables and chairs. So I just said, for our purposes, we're going to use 7 net. So you're going to describe that space as having chairs only, and they're not going to be fixed. So that's pretty much like our atrium at the college. We can set that up for assemblies. People come in and watch graduation, and then they go away. So that atrium space is going to use 7 net. So for any office spaces, so we have administrative.
I think you're muted.
Reading rooms, and there's another one for the stack. So that complicated that just a little bit. Can you guys hear me? Because I'm getting something that says my internet is stable.
Yeah, it sounded like you cut out there for a few seconds.
Okay.
The last thing we heard was the business areas, 100
Oh,
goes.
the business areas. Okay, thank you. So educational, that's going to be 20 net. So that's one of the ones where we have to calculate that perimeter value. And the assembly space, we have to calculate that perimeter value. And also for the educational space. These are all net values. And then for the library, for the reading rooms, because that's where people do tend to gather more, we have to calculate that net because we're trying to make sure that those people get out of the space. For the stack areas, it's gross because that tends to be more books than people. So they're imagining you're not going to have to worry about evacuating that many people from the primary book storage area. So we only have to get the gross value there. So that's the rationale behind that. So this is a slide I think I've gone over a couple of times with you before. This is nothing you're going to find in a book. This is a formula that I invented, but it is useful. It's useful until you get in a stream. If your room starts to become a quarter, or your room starts to become a quarter, that formula breaks down, and you're just going to have to do it manually. But rather than just sitting down, measuring each of these areas and subtracting them, I said, well, we can use our basic, 8th grade algebra and do this type of problem. So this is a formula I made up, but for the most part, it works. So anytime you're calculating the net value, what this perimeter area is trying to do is to give 44 inches because that is the minimum width that is required for you to get out of a building that is sprinkled. And if you remember, we said multiple times, we've decided we're going to sprinkle our building. Most buildings are sprinkled these days. If your building is not sprinkled, however, that perimeter width goes up to 48 inches. But we're using that 44 inches because we're going on the assumption that we're going to pay for sprinkling this building. So sprinkling the building, the reason why, is because that buys you more time to get out of the building. So you can have fewer people going down that corridor at one time because you've bought more time with that sprinkling system. So I'm hoping that if you understand that these are not just arbitrary rules, that you understand there is a kind of logic behind them, that it may stick with you a little bit more. So all we're doing anytime we're calculating that net value is that we're taking the width of the room and the height or the depth of the room. I just called it H. It could be D, or any other letter you want to give that to stand in for those two dimensions. The easiest way I did the rest of them was I just got the square root and turned them all into a square, because that gives me a nice proportion room. But as long as the room does not go into quarter type spaces, this formula is going to work. So area is simply the gross area, B times H, we know that. But what we want to do is get the total area with that perimeter subtracted, because the number of people that we can get in that space is going to be defined by that inner area, not by that outer area. So how many people can we get in that space depends on the calculation of that. So BN, that's just B net, equals B, the width of the room, minus 2P. P is simply that 44-inch perimeter, which I'm showing here, and I'm showing here. So I just went ahead and took that 44 inches, and then I changed that to feet, so we're always working in the same units. So that became 3.67 feet. So you see that throughout all the problems today, to get at that 44-inch perimeter. So after that, it becomes fairly easy with this formula. You say, well, B net equals B minus 2P, because I have a P over here and I have a P over to the other side. So I'm taking that width and I'm subtracting that distance right here from that edge. Can you guys see my cursor? Can you see my cursor? Okay, great. So I'm subtracting that amount of length, 3.67 feet, and that amount of length, 3.67 feet, from the overall length. That's all that's doing. And then I'm taking the overall height of the space, or depth of the space. I guess I really should have called that D for depth of the space, because height is typically vertical. But for all purposes, we'll just call it height, or H. H net value, I'm simply going to take the total H, and I'm going to subtract that distance right there, which is 3.67 feet, and that distance 3.67 feet. So that's why H net equals H minus 2 times 3.67. The 3.67 is here and here. So then we go back to 8th grade algebra, and you can simplify this if you want to. You can do this much faster. You don't have to write it all out like that. I just did that to make it super clear. So there's shortcuts even through this, but going back, again, the 8th grade formula, you just multiply 8th grade algebra, multiply everything. So then I multiply the 2P and the H, that's minus 2PH. And then I have minus 2PB, because I'm multiplying that one times that factor. And then we multiply the n values together. 2P times 2P is 4P squared. So that's that in a nutshell. So any questions so far on that? Because if you understand that formula doing the rest of them, anytime you calculate a net value, it should be fairly straightforward for you. This is the tutorial, guys. This is the tutorial we're getting. So any questions on this at all?
I have a question, Professor. So if you have a different form, do you just change it to be rectangle and then, or like this form, and then you just do the formula?
No, you're going to have to do this. So that is a good question. You're going to probably have to do that more manually. I don't have a formula for, let's say you have a